We've been talking about how to solve systems by graphing, and we're getting ready to review solving system algebraically. So I just wanted to kind of go over the definition of a system, its solutions, and how we can check to see if that ordered pair or that ordered triple is a solution to our system. It says when used together, these form a system of equations, which is a set of two or more equations with two or more unknowns or variables. The solution to a system lists the values that can be used for each variable to make the equations in the system true or check. And so we're going to be looking at that check part. In this first sample, this is a 3 by 3 system of equations because it uses 3 variables and has 3 equations. Alright, says which of the following would be the solution to the system? So I have an A choice, a B choice, and a C. And notice I have an X, Y, and a Z. So we're looking to see what ordered triple would be a solution to this system. So to do that, I'm just going to plug the values in for X, for Y, and for Z and see if they make each of these equations true. So in A, I'm going to put -4 in for X. I'm going to put -1 in for Y. And I'm going to put +2 in for Z. That gives me -8 plus a -3, which is -11, minus a +8, which is -19, not -3. Therefore, I know A is not the solution to the system. Alright, let's look at answer choice B. This time I have 9.5. I have 0 for X, and I have 5.5 for Z. So 2 times 9.5 is 19 plus 0 minus 4 times 5.5, which is 22. That equals a -3. So now I'm going to check the next one. I have 9.5 minus 5.5. That equals 4. So that's true. And then I'm going to check the last one. I have 9.5 for X, I have 0 for Y, and I have 5.5 for Z, and I want to check to see if that equals 4. So I have -9.5 plus 0 plus 3 times 5.5, and that gives me gives me 7. That's not 4, so it doesn't check for all 3 equations, which means B is not the solution to the system because it would have to be true for all 3, which means C must be my correct answer, but I want to go and check it to verify anyway. So let me erase this and let's check it. So I'm going to put 5 in for X, I'm going to put -3 in for Y, and I'm going to put 1 in for Z. So I have 10 minus 9, which is 1. 1 minus 4 is -3, so it checks the first one. I have 5 minus 1. 5 minus 1 is 4, so it's true for the second one. I have -5 minus, plus -5 plus 6, which is 1, and 1 plus 3 is 4. So it's true for all 3 equations, therefore C is the correct answer for this 3 by 3. So my solution would be an ordered triple of 5, -3, +1. Alright, let's look at another example. And sample 2. This one is a 2 by 2 system of equations because it has two variables and has two equations. It says which ordered pair, and I notice this one is called an ordered pair, shows the solution to the system. And I'm going to do the same thing. I'm going to put 15 in for x, 3 in for y, and do I get 9? 30 minus 21 is 9, so that checks. I put 15 in for x and 3 for y. Is it true? Well, 15 halves minus 3 is not equal to 3. Therefore, A is not the solution. All right, we're going to check it for B. All right, I put 8 in for x, 1 in for y. 16 minus 7 is 9. I put 8 in for x, 1 in for y. Half of 8 is 4. 4 minus 3 is 1. B is correct. That is my correct answer. Okay, so in order to check to determine if a solution is a solution for that system, it has to be true for all the equations in that system. Alright, I want you to do 3 and 4, and we will check to see if your answers are right in class. See you in class.